Hi, in this video I'm going to talk about functions, and we're going to start with just defining a few words before we jump into functions. Let's take a look. Now your table of contents will be set up like this, and you want to add these reference numbers to it. We're going to start with domain and range. The domain is a set of x values in a set of ordered pairs, and the range is a set of y values in a set of ordered pairs. So let's take a look at an example. When I have a set of ordered pairs, the domain will appear in the x column and the range will appear in the y column. Now there's a little mnemonic device that will help you remember this, and you can see it. It's doctor. So hopefully you will see that D maps itself to x and R maps itself to y. The domain in this particular example is the numbers 3, 5, and -7, and the range is 2, 0, -4. Now if a value repeats itself, you just have to write it down one time. Okay, so that leads us to the definition of a function. A function is a set of ordered pairs in which the domain, in other words the x values, do not repeat. So if the x values do repeat, it's simply not a function. Now f of x does replace the y variable for several reasons. One, if you have that notation in place of y, you can immediately tell if it's a function, because you can't use that notation unless the equation is a function. So that would be probably the most important reason why this notation is used. You can't look at equations often and tell if the x value repeats itself. Another way you can determine whether or not something is a function is by using the vertical line test. If you recall from Algebra 1, this is kind of like, think of a scanner, a pencil that is scanning across your graph. If the pencil touches the graph in more than one place, that just simply means that the x value just repeated itself there. So in order for it to pass the vertical line test, the graph can only touch the pencil at one point during the scan, okay, during the vertical scan across the page. So let's look at this example here. This is the same as that. I don't have to use the letter F for the f of x. I can use G, H, whatever letter suits the situation. So don't get locked into just the F. Okay. So now I want to take a look at how to find the domain and range of a picture graph. So the first thing you're going to do is you're going to kind of draw a box around the graph, and you want each point on the graph to hit your edges. So my box would look like this. Now that I've created the box, I can figure out what the domain is. Okay. So the domain again maps itself to the x-axis, or the x values. So my most left point begins at -4, and the furthest it goes is +4. So the real estate of that graph lies in between -4 and +4. And this is how we would write that. Another way we can write that is using interval notation. We talked about this earlier. So either one of those formats are correct. The range is going to deal with the y values. The lowest y value is also -4, and the highest is +4. So in this case, we're going to put the y in the middle. So the real estate for the range also falls between -4 and +4. Once again, we can use that same notation for this graph. Alright, so if you want to think of the domain as the walls of the graph, you can, and the range as the floor and the ceiling of the graph, that's another option, just in layman's terms, so to speak. Let's take a look at this one. This one is a little bit different. Every graph is different, and so I want to kind of expose you to different situations. We can't really draw a box around this graph because it's just a line. So, but I can determine where it begins on the left side and where it ends on the right. This will give me my domain. It begins at -3 and it ends at 5. And again, we can set it up in interval notation. The range is what gets tricky because the floor and the ceiling, so to speak, are one and the same. So every point on that line, if I were to... Okay, I'm sorry, I had to pause the video for a couple minutes, so I hope I pick up where I left off here. If not, try to piece it together. So let's talk about the range and why it's equal to 3. If you were to list every point on that line, the y-coordinate would always be a 3. Just test it out. Pick a few points on that line, name the point. Your y value is always 3. It never gets to alter. It is always going to be 3. And so that's why your range is only the number 3. Okay. And here's another one that's kind of got some special situations to it. You see the arrows on the end of these of this graph, which means it extends off into the wild blue yonder, into eternity. So the domain is, we really can't construct a box around it because it's continually expanding. Think of the walls just continually going out. So the way that we would write the answer for the domain would be all real numbers, or in interval notation we would write it -infinity to +infinity. The range, in like manner, is also all real numbers, because if you think floor and ceiling, those two things are both expanding as well, continuing to go upward and downward. So there's really no definite floor or ceiling to that, so that's why it would also be all real numbers. And that concludes this video.